Okay, so next point you need to keep it in mind while doing the retrosynthesis analysis. If FGI is needed, do it at an appropriate stage. So do it at an appropriate stage to get the desired effect on the orientation. So here is an example: 1-chloro, 4-trichloromethyl 1-chloro, 4-trichloromethyl benzene. And if this is the target molecule, and if you want to do the retrosynthesis analysis on this molecule, then you can propose two types of path. Let us assume, let's go with the path A. During the path A, the CCl disconnection. So you're planning to do the CCl disconnection. After the disconnection of CCl, you will get this kind of synthetic equivalent, that is trichloromethyl benzene. Cl minus and benzene. This is yeah, of course. This will carry a negative sign, and protonation of this, and this will carry a positive sign. This will be acts as an electrophile. So trichloromethyl benzene, your synthetic equivalent. Then next comes is how to simplify this further. So simplification, because you need to get this simple molecule toluene. Toluene is can be easily available in most of the labs. That's why your aim is to start with the toluene. Suppose if you have a toluene, then is there any method is available? So can we use FGI step in this particular step? So FGI cannot be implemented particularly at this stage. So wherein you cannot convert this, you cannot substitute the existing CCl3 with the CH3, because there is no such reactions which can be used for the conversion of the CH3 to CCl3 if you are trying to implement the FGI particularly in this step. So that's why the path A can be ruled out. Now let's check the path B. So in the path B, so first itself you are planning to convert this existing CCl3 into the CH3, that is FGI. So substituting this already presenting group with the CH3. And later you are concentrating on the CCl disconnection. The CCl disconnection, the CCl disconnection, if you do it, then you will get the toluene. So in both the cases, you will get the toluene, right? In path A and path B, also if you follow, the starting material is toluene. But you need to be cautious whether do we need to follow the path A protocol or path B protocol. Why path B protocol is preferred? Why path B is preferred? What will happen if you follow the path A reaction? Concentrate on this particular. So if you follow path A, then what will happen is this is actually an electron withdrawing group, and in order to construct this target molecule, you need to use electrophilic substitution reaction. So this is an electron withdrawing group. It prefers to redirect the electrophile E flag over the meta director. Then after the reaction, you won't get the para substituted Cl. Instead, you will get Cl particularly at this site. So that's why this is actually a meta director group. Electrophile doesn't attack at the parasite, and you may not get this particular target molecule. That's why you need to follow path B. And here the CCl3, in the path A is a meta director. But if it FGI the CH3, you can do the FGI in the first step itself in the path B. Propose the FGI, convert this CCl3 into CH3. So you know that CH3 is a para director, right? So you need to introduce the FGI step as and when required, because you know the next step of the reaction is CCl cleavage, and it should be at the para to the substituent which is already present. So in this case, you need to introduce the FGI step prior to the CCl cleavage. So if you follow the path A, the FGI step is introduced at the second step. not in the beginning of the CCl cleavage. So that's why you should be very clear when to introduce the FGI. So FGI step needs to be introduced at an appropriate stage to get the desired effect on orientation. So here CH3, convert the first substitute CCl3 with the CH3, then CCl disconnection, you need to think about it. Then CCl disconnection leads to the formation of toluene, is the synthetic equivalent. CH3 is a paradirectional, therefore do FGI prior to the CCl disconnection. Okay, so let's look into the synthesis of the same target molecule. Start with the toluene, then you need to use Cl2. So that is chlorination, right? Electrophilic substitution, FeCl3 if you can use it, then electrophilic substitution. The site of reaction is, of course, you will get two types of product in this case. One is ortho as well as para product substituted. So you need to separate the para product because there is no option you will be having. The para product you need to isolate it. Then further is chlorination once again, wherein you can convert this CH3 into CCl3. So this will be the target molecule. So in order to get this target molecule, you need to use Cl2 and chlorination reactions in the later steps to get target molecule.